going to explore the topic design thinking based smart temperature control using PID controller. In modern engineering world, maintaining a accurate temperature is a critical one. So for this purpose, we are going to use the design thinking approach for smart temperature control. The smart temperature control be required in so many fields, that is industrial automation, electrical vehicles and chemical plants and automation systems and so many engineering fields. If we consider traditional temperature control methods means the output will not be an accurate one. So it gives the fluctuate output and the voltages are give the more fluctuations and the uncomfortable and energy wastage one. If we use a smart temperature control using the PID controller means we can get the accurate temperature maintenance, and design thinking based approach means we are using 5 stages, that is empathy, define and ideate, prototype and output. So for this, the empathy part is going to tell by Electrium.
So in the empathy stage, we are studying the user and the temperature issues. In the hospitals, the raw temperature may affect the patient's safety, and also at the home, the unstable temperature may affect the discomforts by the users. And also in industries, overheating can damage the machines for running, and so that the users can face the slow response and the high power consumptions. So we need to fast and the reliable automatic temperature response. So the next stage can be explained by Dinesh.
Understanding the user's problem, we have to look at different stages. In this stage, we have mainly Excel. In the Excel, there are actually problem statement. We found that the existing temperature control system have many issues like temperature changes continuously over to overheating or cooling.
So in this stage, we have identified the temperature issues problem. So we have to find the slow response and also the overheating temperature issues. So we have to find the solution for this by using an automatic and also an accurate temperature control machine.
So after defining the problem statement, let's move to the ideate stage. So in this stage, we are going to find the best possible solution to our problem statement. So we have several control system methods. So our first method is on-off controller. In this, when the temperature is too low, the heater turns completely on. And whereas when the temperature is too high, the heater turns completely off. So this system is not efficient. So next we have our second method, which is the manual control system. So in this method, a person continuously needs to check the error or the temperature changes and adjust the temperature continuously. So this method is not efficient. Next we have a third method, which is the PID controller, which is the best possible solution to our problem statement. Because the PID stands for P for proportional, I for integral and D for derivative, where the PID controller continuously checks the error between the desired value and the actual value and rectifies the error. So this system has more advantages when compared to the other methods. The equation for PID controller from which it works is this equation, which is U of t equal to Kp E of t plus integration of Ki E of t dt plus Kd E of t d by dt. So in this, the Kp stands for proportional gain or constant, and the Ki stands for integral gain or constant, and the Kd stands for derivative gain or constant. The advantages of this system is that it reduces temperature fluctuations and reduces overshoot, and it maintains a stable system. Next we can move to our prototype stage by Arisum Saha.
So if I speak about build a smart temperature control system using PID, we would require 5 components. One is Arduino, the main control, which will control the whole system. Next, we'll use a DST11 sensor, which monitors the temperature and humidity, which will monitor the temperature and humidity of the environment. Next, we'll use a relay module, which will short and open the circuit Next, we'll use a PID controller, of course, the proportional integral and derivative control, which will accumulate the error and try to control, try to reduce the errors. Next, we'll use a cooling system, which is a 5 volts DC fan. So, if I speak about how will it work, first we'll keep a set point temperature. Let's keep, for an example, let's keep 30 degrees. This will be the main get through our temperature sensor. But the temperature sensor, if it detects like 26 degree or 25 degree, there will be an error. The set point error minus the minus the temperature of the temperature sensor. Let's take 4 degree as the error. So then the error will be monitored by the temperature sensor. Then it goes to the PID sensor, which will try to bring back into the set point, which is 30 degree. And what will be the role of the PID controller? In proportional controller, we will be finding the present error. What is happening? What is the error? Which is a 4 degree error. It will find and give a quick response. In the interval, it will find the steady state error, and but there is a disadvantage of integral controller is that it will give a heavier overshoot. If we speak about the derivative controller, it will give the future errors. What can be the possible errors in the future? Example, any overheating or short circuiting, something like that. The advantages of PID controller is that it would give a faster response. It will be efficient, and it can be multi-purpose. It can be multi-purpose thing. If we speak about applications, it can be used in house appliances, industrial appliances, chemical industries, and also automation industries. So this is all about the design thinking on smart temperature controller using PID controllers.